Next, we'll talk about questions which is based on distance formula and also based on the geometrical application of distance formula. So first question is find the distance between the pair of points 2, 3 and 4, 1. So in order to find the solution of it, what we'll do, we'll take it as a point A whose coordinate is 2, 3 and the point B whose coordinate is 4, 1. Now this will compare with x1, y1 and x2, y2. When you find, you will observe that the value of x1 is 2, y1 is 3, x2 is 4 and y2 is 1. Now apply the distance formula. We can write AB equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. On substituting, we'll get 4 minus 2 whole square plus 1 minus 3 whole square, which will be square root of 2 square plus minus 2 square, which we can write it as 4 plus 4 under root, and that can be written as root 8 whose value is 2 root 2 units. So this is how we can find out the distance between 2 points when the coordinate of points are given. Next question is determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. So in order to check whether the points are collinear or not, we'll have to find the distance between each 2 points, and then we'll use the concept what we have studied to find whether they are collinear or not. So we'll take let A equals to 1, 5, B equals to 2, 3 and C equals to minus 2, minus 11. Now again, if I'll see the distance formula, we'll write square root of x2 minus x1 whole square plus y2 minus y1 whole square. So when we are talking about A, B point, you can take any one point as x1, y1 and the other will become x2, y2. Or in the simple term, we can remember it as difference of x coordinate whole square plus difference of y coordinate whole square. So we can write it as 2 minus 1 whole square plus 3 minus 5 whole square, which will be square root of 2 minus 1 is 1 square plus minus 2 square, which will be 1 plus 4 root 5. Next, when we find the distance between BC, so that we can write based on the same distance formula, it will be minus 2 whole square plus minus 11 minus 3 whole square, which will be equals to minus 4 square plus minus 14 square, which can be written as 16 plus 196, which is 212. Next we have AC. So when you find the distance between AC, it will be minus 2 minus 1 whole square plus minus 11 minus 5 whole square, that will be minus 3 whole square plus minus 16 whole square, which will be equals to square root of 9 plus 2, 56, which will be square root of 265. Now here what we observe is that if you add any two length, we will not get the third one. So since here we can say that AB plus BC is not equals to AC, therefore points are not collinear. The next question, where we have to check that what type of quadrilateral it is. So we have to name the type of quadrilateral formed by the points 4, 5, 7, 6, 4, 3 and 1, 2. So again, we will name these points as let A equals to 4, 5, B equals to 7, 6, C equals to 4, 3 and D equals to 1, 2. Now in order to prove that what type of quadrilateral it is, we are going to find the distance between each two consecutive vertices, and also we are going to find out the length of diagonals. So if I'll use the distance formula AB, which will be square root of x2 minus x1 whole square plus y2 minus y1 whole square, we can write the value of AB as 7 minus 4 whole square plus 6 minus 5 whole square, which will be equals to square root of 9 plus 1, which is root 10. Then if you find the BC length, we'll get 4 minus 7 whole square plus 3 minus 6 whole square, which will be equals to square root of 9 plus 9, which will be root 18. Next is CD. The length of CD will be 1 minus 4 square plus 2 minus 3 square, which will be 9 plus 1, which will be root 10. Then DL length, it will be equals to 4 minus 1 whole square plus 5 minus 2 whole square, that will be root 9 plus 9, which is root 18. So what we observe here is opposite sides are equal. Let's find out the length of diagonal. So we will have the diagonal as AC. So the length of AC is, it will be 4 minus 4 whole square plus 5 minus 3 whole square. We'll get 0 plus 4, which will be root 4, and the value is 2. Next, the length of BD, that will be square root of 7 minus 1 whole square plus 6 minus 2 whole square. On solving, we'll get it as 6 square is 36 and 4 square is 16, which is root 52. So what we observe here, that since AB equals to CD, BC equals to AD, and AC is not equals to BD, therefore ABCD is a parallelogram. So this is how we can check that what type of quadrilateral it is if the points are given. Next question is, check whether 5, minus 2, 6, 4 and 7, minus 2 are vertices of an isosceles triangle or not. So if you have to find out what type of triangle it is, so we are going to take again the points as ABC and we'll find the distance between each 2 points. Now here in this case we'll take let A equals to 5, minus 2, B is 6, 4 and C is 7, minus 2. Using distance formula, we'll get AB, that is x2 minus x1 whole square plus y2 minus y1 whole square, which can be written as square root of 6 minus 5 whole square plus 4 minus of minus 2 will become plus 2 whole square, which can be written as 6 minus 5 is 1, 1 square is 1 and 4 plus 2 6, 6 square is 36, it is root 37. Then the length of BC, that will be 7 minus 6 whole square plus minus 2 minus 4 whole square, which will be 1 plus minus 6 square is 36, it will be root 37. Then AC length, that will be square root of 7 minus 5 whole square plus minus 2 plus 2 whole square, which will be square root of 7 minus 5 2 square is 4 plus 0, which will be 2. And here in this case one more thing we need to check, that whether the points are collinear or not. So if you observe in this case will not have sum of the two side length equals to the third. So we can say that since AB equals to BC, which is root 37, therefore triangle ABC is an isosceles triangle. Next question is, find the point on x-axis which is equidistant from 2, -5 and -2, 9. Now these type of questions are very familiar as it involves some of the basic concepts of coordinate geometry. So here in this case it is saying that find the point on x-axis. So since the point is on x-axis, we'll let the point on x-axis be Px, 0. Since point is on x-axis, y coordinate will be 0, and we'll assume A equals to 2, -5 and B equals to -2, 9. It is given. So here now, as per the question, it is given that the points are at equal distances. So we can say that PA equals to PB. Now if you use the distance formula, we can write the distance between PA will be x minus 2 whole square plus 0 minus of -5 is plus 5 whole square equals to square root of x minus of -2 is plus 2 whole square plus 0 minus 9 whole square. Now when you square both sides, the square root will get cancelled and we'll get here x minus 2 whole square plus 5 square is 25 equals to x plus 2 whole square and minus 9 square is 81. Now if we'll expand using a minus b and a plus b whole square identity, we'll get x square minus 4x plus 4 plus 25 equals to x square plus 4x plus 4 plus 81. So here x square 4 and 4 will get cancelled. Now we'll collect all the variable to one side. So we'll get, if you transpose the 4x to the right, you will get 4x and 4x, that is 8x. And if we'll transpose 81 to the left, we'll get 25 minus 81, which will be equals to 11 minus 5 is 6 and 7 minus 2 is 5, that will be negative, and so the value of x will become minus 7. So we can say that therefore point is minus 7, 0. The next question is, find the relation between x and y such that the point xy is equidistant from the point 3, 6 and minus 3, 4. So again it is the term equidistant. We'll name the points. So we'll take let P equals to x, y, A equals to 3, 6 and B equals to minus 3, 4. Now it is given that the point P is equidistant from A and B, so we can say PA equals to PB. If we use distance formula, the distance between PA, that is x minus 3 whole square plus y minus 6 whole square, that will be equals to square root of x minus of minus 3 is plus 3 whole square plus y minus 4 whole square. On squaring both sides, we will get x minus 3 whole square plus y minus 6 whole square will be equals to x plus 3 whole square plus y minus 4 whole square. Expand it using a plus b and a minus b whole square identity, will get x square minus 6x plus 9 plus y square minus 12y plus 36 equals to x square plus 6x plus 9 plus y square minus 8y plus 16. Now x square, y square will get cancelled, 9 and 9 will get cancelled. So we'll get the value as, if you transpose all the terms towards the right, we'll get 0 equals to 6x plus 6x, that will become 12x. Then 12y, when it will go to the right hand side, it will become plus 12y. And so it will become 12y minus 8y will become 4y. And then we have 36 and 16. If you transpose 16 to the left, what we'll get? We'll get 36 minus 16, which will be 20. So this can be written as 20. Now this will be from both the sides. If we'll take 4 common, we'll get 20 equals to 4 into 3x plus y, and so we'll get 3x plus y equals to 5. And that will be the relationship between x and y. Next question is that if q 0, 1 is equidistant from p 5, minus 3 and r x, 6, find the values of x and also find the distance qr and pr. Again, it is question based on equidistant, so we'll take here pq equals to qr, and based on that, if you use the distance formula, the distance between pq, we can write 5 minus 0 whole square plus minus 3 minus 1 whole square, which will be equals to square root of x minus 0 square plus 6 minus 1 square. On squaring both sides, we'll get 5 minus 0 is 5 square is 25 plus minus 3 minus 1 is minus 4 square is 16, which will be equals to x square plus 25. Now in this case, this 25 and 25 will get cancelled. We'll get the value of x square as 16, which means x will be plus minus root 16, which will be plus minus 4. Remember, distance cannot be negative, but coordinates can be negative. That means x coordinate and y coordinate. Now as we have got the value of x, therefore the coordinate of r will be either 4, 6 or minus 4, 6. Now we'll take when r equals to 4, 6, then the distance qr. So the distance qr will be, in this case, the coordinate of q is 0, 1. So this will be 4 minus 0 whole square plus 6 minus 1 whole square, which will be 16 plus 25, which is root 41 on solving. And the next, if you will take PR, so the coordinate of P is 5, minus 3. So we'll get 5 minus 4 square plus minus 3 minus 6 square, which will be 5 minus 4 is 1, 1 square is 1 plus minus 3 minus 6 is minus 9 square is plus 81. So this will be root 82. Next one is when r is minus 4, 6, then the distance qr will be equals to, it is minus 4 minus 0 whole square plus 6 minus 1 square, which will be minus 4 minus 0 is minus 4 square is 16 plus 6 minus 1, 5 square is 25, it will become root 41, and PR will be equals to minus 4 minus 5 whole square plus 6 minus of minus 3 is plus 3 whole square, that we will write it as minus 9 whole square is 81 plus 9 square is 81. We'll have the value of it as square root of 162. So that is what the value will be there. In this case, even you can write it as 9 root 2 also. So this is how we can solve some of the question which is based on the distance formula and the application of it. So further about it we'll be discussing in our next session, where we'll be talking about section formula, the proof of it, and also the question based on section formula and also the geometrical application of it. Thank you. Take care everyone.